Now for projectile motion, like in Chinese, we call it the 拋體運動. So in Chinese, what does it mean? It means when you throw an object in the air, the motion is called the projectile motion. Now, in general, we define a projectile motion as the 2D motion with constant acceleration. So this one is very important. Now, most likely, we will just ignore the air resistance. Just ignore the air resistance. And because you know this is a 2D motion, that means it will be more complicated than 1D motion. But we still can apply the equation of motion you have used in the 1D. Now, in total, we have 5 equation of motion, if you still remember. I think all of you can remember these very well. But for 2D motion, that means we have two. We have one we call the horizontal motion, and another one is the vertical motion. So for 2D motion, just a second. Now we say that the horizontal motion and vertical motion are independent. And in other words, the motion, you can consider project motion as the combination of the horizontal and vertical one. So actually, I want to explain what do I mean here. By looking at this diagram, the diagram on page here, okay. So by looking at the video, by looking at the photo here, so can you see that it shows you the motion of 3 balls. The gray one, actually for the gray one, what you can see, this is just you just release the ball from west and it just drop vertically. And then for the shaded one or the black one, they are just a ball with some horizontal initial velocity. And you know the black one will have the largest horizontal velocity than the gray one, than the shaded one. Now, what do I mean by you can decompose a motion into 2 parts? So let's take a look at the motion of the black one, Now, I draw another ball here. So the red one is moving horizontally with uniform velocity. So that's why you can see, okay, for every after each time instant, it travels the same distance as shown in the diagram. Now, can you see that, okay, the black one always have the same horizontal position as the red one. And they also always have the same vertical position as the gray one. Can you see it? That's what I mean by the projectile motion. That is the motion of the black one. It's a combination of the red one and the gray one. Okay, so that's what I mean. That's when we analyze the motion of the projectile motion, we can always decompose it into 2 components. So one is the horizontal motion, another one is the vertical motion. Now usually we just use 2 of the equation of motion, just these two, normally. Now, and then if you want to, and then we will make it to be 4 equations. So 2 is horizontal. These 2 are horizontal. So these 2 are vertical. Actually, I didn't change anything. I just make the V be Vx, U be Ux, A be Ax. I speak in Cantonese. So S will become X and then S become Y. Okay, can you see it? Understand? I didn't change anything else. I just rewrite these 2 equations into 2 horizontal motion and vertical motion. Any questions here? And then we are going to talk about one very simple case, this one. So you project the object horizontally. And then let's take a look at, now we need to, first of all, need to, hi. You're asking? No. You're asking a question? No. Now, then we, first of all, we let the horizontal axis X to be axis to the right side. Then the vertical axis is the axis downwards. Okay? Now you can let the vertical axis to be upwards. Okay? But let me tell you the differences later on. But it's more general to let the axis to be downwards in this case because the object is moving downwards. Is it? Now then how can we write down the equations? Now if you remember, we have write down the equation. We write the equation like these 4 equations. Just a second. I want to write on the web file.點解我咁蠢咧？點解我唔攞 copy and paste 咧？算啦。Okay, these 4 equations are coming from V equal to U plus AT and S equal to UT plus half AT squared. The next step, what we need to do is, so for the initial velocity U, now this is horizontal. So that means UX should be U and UY should be 0. There's no vertical components. The initial velocity has no vertical component. Okay. Then how about the acceleration? Now you know the object, when the object is in the air, the acceleration is always downwards, G. So this acceleration is vertical. So that means it has no horizontal component. AX is the horizontal component of the acceleration. AY is the vertical component of the acceleration. The vertical component of the acceleration will be just G. Okay. Then what we need to do is just substitute all the values in these 4 formula. Now let me know if you have any question, okay? I let you to have the pool. So any question about this 4 equation? This 4 equation is the this is the most simple case already. Now you understand, okay? You're just starting from V equal to U plus AT and S equal to UT plus half AT squared. But what question do you have? Hello? Hello? No question. Now we're starting from 係啦，咁你見到啦，我哋 starting from these 2 equations 嘛，and then we make it to be 4 啦，2 are horizontal, 2 are vertical, and then we substitute the initial conditions. So and also the acceleration. So we substitute the initial velocity and also the acceleration into the formula, and then we get this 4. And actually, this 4 equation, that's explain why this diagram look like this one. Come on, because the horizontal is, you can see the horizontal velocity does not change. It always travels the same horizontal distance at equal time interval. Now then, let's take a look at the summary here. Now in this case, we know that the horizontal velocity is constant. And equal time, you have the equal horizontal displacement. And vertical motion is independent of horizontal velocity. So you can see the the black ball, the gray ball, and the shaded ball, they all have the same vertical motion. And also the time when they hit the ground for these three balls are the same. Okay. Then take a look and let's solve this question together. So Richard plays a game in an amusement park. He throws a ball behind a bench to hit the target 3 meters away, to hit here. So and then now, what you know about what is free? Now let me rewrite the formula. We have derived. But we are lagging behind. Kenji, can you tell me what does the free mean in the formula? Hello, Kenji.
Hi.
Hi. What is free in the formula?
X.
X am I? Because X is a horizontal displacement. So we replace the X to be 3 Y to be 0.4 啦，係咪? And can anyone tell me which formula? Sorry, which one of these 4 equations is useless? It can't help you calculate anything. Do you know? No, actually, the first one is useless. It just tells you that the horizontal velocity is always constant, equal to the initial horizontal velocity. It didn't tell you anything extra. Okay, so this one, actually we don't need to use it. So then we just solve this equation, and then which one will start first? Hello. 1, 2, 3. Which one will you start? Which equation will you start to solve? Abhijit, which one will you start first?
Third one.
The third one, is it? Because for the first one, there are 2 unknowns there. You don't know Vy and T. The second one, you don't know U and T. The third one, you just don't know one unknown here. So you use the third one and then you solve the T. Remember the G to be is 9.x1. And then you can solve the time here. Now you can use your calculator. The time will be 0.285 or 6 seconds. After you get the time, you can substitute in the first equation and the second equation to solve the U and solve the Vy. Then the U will become 3 divided by the time, 10.5. The Vy will be 2.81 meter per second.
Mr. Yang，我想問下個 G 點樣揾㗎？
G is a 9.x1. That is the acceleration due to gravity.
Oh, okay, thank you.
So then, for the first one, for part A, we have solved it already, is it? So it's 0.286 seconds. The second one is the initial velocity, that's U, should be 10.5 meter per second. 好啦 Joshua, how about part C? How about the velocity of the ball when it's at the point B? Now, some of you may think that the answer should be 2.x1, but It is not.
Isn't it like a root of 2.81 square plus 10.5 square?
Yeah, because at the point B, the ball is not moving vertically downwards or nor horizontal, is it? But we know the vertical component of the velocity is 2.x1. And you also need to know that the horizontal component is always the same, it's always constant. So it should be 10.5. When the question asks the velocity, it always means the resultant one, not horizontal nor vertical. So you need to use a Pythagoras theorem to find the resultant. So it should be 10.5 square plus 2.x1 square. So this one should be 10.9 meter per second. Can anyone tell me, is there any other way to find the answer in part C other than using the projectile motion?
Relative motion.
No. You can use energy. I think you all have learned about the formula already. So the kinetic energy at the point A plus the potential energy at the point A, then that will be equal to kinetic energy at the point B. That's how the energy converts. So this one, although you don't know about the mass of the ball, but it doesn't matter because you can cancel out in this formula. You can cancel the m in the formula. You can see it. And you're going to solve the v. The h is 0.4 because you know when you calculate the gravitational potential energy, you need to use the vertical displacement. Is it? Then u is 10.5. U is 10.5. You get the same answer. Believe me lah, okay? You get the same answer. Okay. Now then let's move on. Now take a look at another case. So this is a jet dropping a ball. Now at different time, like if the jet is always moving at uniform velocity, horizontal velocity, when the jet drops the bomb, okay, 3, 2, 1, done. Now when the jet drops the bomb, like you need to remember, you need to know that, okay, when the jet drops the bomb. So let's say when the jet is having the speed, let's say 200 meter per second, the bomb will also has 200 meter per second. It's not when the object is moving, when it drops an object, and that object will not have the zero speed. It also has a speed of the jet. So it's also 200 meters per second. So that's why if you look at this diagram, the bomb is always below the jet. Because the jet and the bomb, they all have the same horizontal velocity. They always have the same horizontal velocity. Okay. Any questions? No. So that's why if the jet drops a bomb, what will the jet do afterwards? So let's say this one is an atomic bomb. So what should the jet do afterwards? After dropping, either accelerate or moving backwards, is it? The best way is moving backwards. Hello. 好啦，嗱，then 嗱，you take a look at this question, okay? I'll give you some time to do it 啦嚇。嗱，you take some time to do it 啦。嗱，you send me your answer 啦嚇。You send me your answer like true, false, true, true, false, something like that 啦嚇。The first one 咧 is true 嘅，because we said that these two objects always have the same vertical motion. And these two always have the same acceleration, that's g. And then these two always have the same vertical motion. That means they always have the same vertical anything about vertical is always the same. So they will have the same vertical speed on reaching the ground. But they don't have the same speed. Do you know why? Because Q has also a horizontal speed other than the vertical one. Now these two vertical speeds are the same, but Q has a horizontal speed. The resultant speed or the speed of Q, it should be larger than that of P. If P is giving a greater initial horizontal speed, it reaches the ground with the less time. No. Even V has a larger horizontal speed, it still has the same vertical motion as P. So therefore, the answer should be true, 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 false, false. Okay. Then let's move on. All right, this is the past paper. Okay. Maybe do you want to do it? Do you want to do it? Now maybe I'll pause the video first. The time taken for the ball to fall from A to B, we just look at the horizontal motion. Now you know the formula we have derived, x equal to u plus a, x equal to ut. Then it should be 0.43, then equal to 1.1 times t. Then you can solve the time. How to determine the height? Then we just use y equal half gt squared. Then you substitute the time, then you can get it. Okay, that's it. Nothing else. Okay. So the next one is lift the ball, draw the acceleration of the ball. The acceleration is always constant. It's always 9.81. So that's why this should be a horizontal line. If you're talking about the vertical components of the displacement, then you take a look at this formula. You know it should be a quadratic function. Then I think you have learned about how to draw this graph. So this should be a curve. Okay. The next one, the ball of the greater mass projected on from table with the same velocity. How about if you're using a larger mass? The heavier ball and then on the time taken for the ball to fall on the ground. So there should be no effect. Or you can say the same time. Because you will say that the acceleration is independent of the mass. It does not depend on the mass. Okay. So no matter, and also you can see that from this equation, we don't involve the mass in this equation. So that means the mass is independent. All the things, anything about the speed, in velocity, time, acceleration are independent of the mass. Okay, so that's why there's no effect. They will fall to the ground on the same time. Done. 好啦，these are the Hong Kong A-level exercise. So I think I don't want to do it. Because I think this somehow a bit easy, yeah. But you take a look at the first one, MC number 1. It projects horizontally with the speed u. And then after some time, it hit the ground at the velocity v. Find the time of flight. You miss a lot of things. Yeah. Later on, this is not the core part of the projectile motion. Now, how can we do this question? Now, you can remind yourself about the formula you have. Now, I don't use x and y because you don't have the horizontal displacement and you don't have the vertical displacement. You can't use it to find the time. So that's why I just use these two equations to find the time. Now, not obviously, to find the time, we must use the second one, right? Because the first equation has no time there. So that means you need to find the vertical velocity. Find the vertical velocity. How can we find the vertical velocity? V is not the vertical velocity. V is the speed, or you call the resultant speed. So you need to decompose the V into vertical and horizontal. Now you know the horizontal velocity does not change. So that's why the horizontal velocity is always u. Then how can we find the vertical velocity? We can just make use of the Pythagoras theorem. That's it. So it should be v squared minus u squared. Then just make use of this equation. Then you can find that the answer should be d for dot. Okay. Okay. Another one, maybe let's take a look at MC number 3. So the object is thrown horizontally from the top of the cliff at the speed 20. So find the speed of the ball after 3 seconds. Now after 3 seconds, the horizontal velocity unchanged. And it also has a vertical velocity. To find the vertical velocity, we use g times t. So it should be 9.x1 times 3, around 30. Around 30. Then to find the speed after 3 seconds, then we just make use of the Pythagoras theorem. Then the answer should be 36. Okay. I hope these questions are simple. You can do the remaining two by yourself. But the MC number 2, you also need to use the knowledge in energy. Then let's move on. Then let's go on to talk about a more general projectile motion. That's what the question normally the question would be like. Now for a general horizontal motion, for a general projectile motion. Now for a general projectile motion, the initial velocity has some angle with the horizontal line. Now, then we need to also set up the x-axis and the y-axis. Then normally we will set the vertical axis to be upwards and the horizontal axis to be to the right. Hold on. Then you know that the path of the object will be like like this one, Now we are always starting from the two equation now, V equal U plus ATR, and then S equal to UT plus half AT squared. And if you still remember, then we need to expand it to 4. Oh, the acceleration is always downwards. That is G. Oh, Kenji. So what is AX and AY? Kenji.
Hi.
Hi. So what is AX? Yes. Hi. So what is the horizontal acceleration? What is the horizontal acceleration? Hi. 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 It should be 0, lor. Because the acceleration is vertical, ma. Then it has no.
係咁啦。
好，then it's 0 lor. How about the AY 咧？係啦，we need to take it to be negative G, because I let upwards to be positive. I let upwards to be positive, downwards to be negative. Then the acceleration should be negative G instead of positive G. It will be more general or natural to let upwards to be positive, because in this case the object is first moving up and then moving down later on. And you can see that the vertical displacement of the ball is always positive, unless unless the object is falling above a cliff, then you may let the work downwards to be positive as you like. It doesn't matter at all. But in this case, I just let upwards to be positive. 好啦, how about the initial velocity? Remember, the initial velocity is neither horizontal nor vertical. We need to decompose the velocity into 2 components. How about the vertical one? Rainbow 咧? What will be the answer for the vertical initial velocity? Joshua 咧?
Initial.
Yep. After you decompose the U, the initial velocity, into 2 components, one is vertical, one is horizontal. So what is the value of the vertical one? Now, do you know what is meant by components? We talked about this long time before when we talk about the vector. So we said that this vector can be write as a sum of these 2 嘛，係咪？係咪？ We can write it as the sum of these 2 vectors 嘛。Then we can make use of trigonometry 咯 to find it 咯。Joshua, what should be the green one in terms of U and theta?
Maybe sine
Yeah, it should be U sine
theta.
theta. Then the purple one should be U cosine theta. So this is a UY and this is a UX. Okay. Then what we need to do is substitute into these four equations. So I'll give you some time to digest it. After you digest it, you need to absorb it, not to secrete it to the toilet. And you need to write down, you need to be able to write down this equation as 1 + 1 = 2. Okay. Many questions for these four equations. Now then we need to make use of these four equations to solve all the other stuff from now on. Any questions here? If you have any questions, just let me know first. Otherwise, you don't understand anything yet later on. Let's also take a look at this diagram. Okay, this is always a very good diagram. So you can see the black ball, the motion of black ball. This is a projectile motion, and you can take a look at the vertical motion. It's exactly the same as the gray one. And for its horizontal motion, you can see that it always travels the equal distance at equal time. Okay. And the vertical motion and horizontal motion are independent to each other. That's what we talked about in the first place. We said that the vertical motion and horizontal motion are independent. Hold up. Then we are going to take a look at the next one. Now, then we would like to also find the maximum height. So what does maximum height mean? So this is the distance. This distance is the maximum height. And then we would also like to find the range that is a maximum horizontal displacement. And also we want to find the time of flight. So that is a time when the ball hit the ground again. Okay. Then we're going to look at these three here. Now remember at the highest point of the motion, at the highest point of the motion. Now we will say that the vertical speed is 0, but not the speed is 0. The speed is never 0 at the highest point. Now if the speed is really 0 at the highest point, then the ball will just drop vertically downwards. It's not a projectile. Then it will not just go forward. Now we just say that the vertical speed is 0 at the highest point. So that means the Vy is 0. At the highest point. Okay. Do you understand why the vertical speed is 0 at the highest point? Now you may just take a look at, compare the highest point here and the highest point here. If you're throwing a ball upwards, at the highest point of this motion, you know that, okay, you say that this velocity is 0. That means in the vertical motion, the velocity is 0. So that is the vertical velocity 0 at this point, not the horizontal velocity. The horizontal velocity is always the same. It does not change at any point of the motion. Okay. Then we can make use of these. Let me write down the 4 equation here because we need to use it later on. Okay. Then for the maximum, for the maximum height, we say that the Vy equals 0. Then which equation should we use?
Second.
The second one, is it? Then what we can solve, we can solve the time. Then the time will be u sine theta over g. So this is a time for the ball to move from the initial point to the highest point. Okay. Then to find the maximum height, so then we use the which one? After we are finding time, we use which equation? Hello? Which one? The maximum height. The maximum height is here.
Fourth one.
The fourth one, is it? Because the fourth one is the vertical displacement. The third one is the horizontal displacement. For the maximum height, it should be the vertical displacement. Then we use the fourth one. So we use a symbol h for the maximum height. Then you u sine theta t啦, then that is u sine theta over g啦. Then minus half g and then u sine theta over g squared 係咪? Then that is the answer for the maximum height. Like in DSC, you are not required to to remember the formula. You need to derive the formula by yourself. You can't just memorize the formula and substitute in the formula. For conversion, you can remember the formula as you like. But I'd rather you need to know how to derive the formula by yourself. So after this session, I hope you derive these formulas by yourself. You know how to derive these formulas by yourself. Okay, then let's move on. So then let's take a look at about the time of flight. So the time of flight is the time to reach the ground. Now, mathematically speaking, at this point is actually the x-intercept. Can you see it? It is x-intercept. So mathematically, it means y equals 0 at this point. Okay, it means y equals 0 at this point. And actually, there's another meaning in physics. Now, initially, the ball is moving. There's a horizontal velocity and vertical velocity. When it hit the ground, just before it hit the ground, we know that the horizontal velocity does not change. And there's also a vertical velocity downwards. Okay.
When it's at the ground, does it still have like the G acceleration?
We're not, we just talk about the motion just before it hit the ground. Then the acceleration is always the same. That's G. So then, remember that the horizontal velocity does not change. And if you're talking about the vertical velocity, the vertical velocity just be when it launched and also when just before it hit the ground, they are equal in magnitude but opposite in direction. So let's say if this one is 10 and then that one will be negative 10. They are always the same magnitude. So we can also make use of this fact. So that is Vy equal to negative Uy. So they are opposite in direction but equal in magnitude. The Uy is U sine theta, right? Then we can go back to here to find the time of flight. Now you can either use Vy equal to negative U sine theta, or you use the y to 0. You will all getting the same answer. Then the time will become 2u sine theta over g. And I hope you also notice that this time is just double the time to reach the maximum height. Can you see that this time double is the time of flight? Why is it like that? Now, because the motion is always symmetric. It's symmetric. Take a look at this diagram. Now, this is the essence of symmetry. The horizontal displacement for the first half and the second half are the same. Also, the time are the same. So that's why it should be double. Okay. Okay. The next one is about the range. Now, for the range, it means the horizontal displacement. Then we substitute in this formula. Okay. Now, of course, the time we use is the time of flight because we are talking about the object. The displacement here, this one. Then the time should be the time for the ball, it should be the time of flight. And then we just simplify it. Now, you also need to remember one identity in mathematics. So that is sine 2 theta equal to 2 sine theta times cosine theta. Okay. So any question for these three? Which part about the last one? The identity or the identity or we are talking about the horizontal displacement. So the blue line. So this one is called the range. This one is called the range. That is the horizontal displacement. So that's why we use the third equation. The time should be the time for the object. The time should be the time of flight. That means the time just before it hit the ground. That is 2u sine theta over g. Then we substitute in the formula. Then we get the range. Okay. In general, to be honest, then that's end for the part for DSE. Now we can take a look at something else. Something else. By looking at this formula, can you tell me what is the maximum range? When will the range be maximum?
When the initial velocity is highest.
Yeah, when the initial is as large as possible, then the range will be as large as possible. How about the angle? So at which angle you give the maximum range?
90? No,
90
45.
degree.
45.
So why 45 degree?
Because it will be sine 90, then sine 90 is 1. 1 is the maximum value of sine, so that's it.
Yeah, I think all of you still remember, the maximum value of sine theta or cosine theta should be 1. Then this maximum value should be 1. So that means the maximum value should be u squared over g. So when will we give you the maximum? When sine 2 theta equal 1. That means 2 theta equal to 90 degree or theta equal 45 degree. That's what you have taught in the PE lesson. When you want to throw a ball to give the maximum range, you should throw it at 45 degree. But 45 degree is just partly true because because when you throw the ball, you are not throwing from the ground, is it? You are throwing from some height above the ground. If you want to throw the ball from the ground, yeah, obviously, if you throw it at 45 degrees, it will give you a maximum range. But if you want to throw it from some height above the ground, then this angle should be a bit less than 45 degrees. It depends on your height. Well, it depends on the height you release the ball. But it should be a little bit less than 45 degrees. Then it can give you a maximum range. We can do this kind of question later on to see at which angle will give you a maximum range. Okay. Oh. Then I think let's pause here first. Okay. Let you to do these two exercises. Now, hold on. Let's take a look at the first one. The time to reach the highest point R. Now, if you still remember, we just make use of the Vy to be 0. The initial velocity, the initial vertical velocity is 19.6. Then you get the time to be 2 seconds. Okay. The maximum height from the ground, then you use Yu to UT lah. U, this is U, T, then minus half GT squared. It should be 19.6 meters. Okay. The next one is about the time of flight. Now you can just double twice the time to reach the highest point R. So it should be 2 times 2, that's 4 seconds. Then the range should be 10 times 4, that is 40 meters. Okay. Any questions here? So for the next one, it's quite similar, but you are just given different things. This time should be 5 per second. Time of flight should be 10 seconds. Okay, just double. That's just twice the time. Maximum height from the ground, then you just use the same formula. I don't solve it. Then horizontal velocity should be 100 divided by 5, should be 20 meters per second. Any questions here? You take a look, or let you to take a look for 1 minute. Now let's talk about the monkey and hunter experiment. Now I want to show you this video. We show you this video. Now, but I'm not going to record this video because of the copyright. So for those who are not in the Zoom, then you just then let's go back to here. Now for this story, monkey and hunter experiment. For this experiment, what you can actually, what is the idea is something like this. Because you know that we consider the monkey as a point. Now you know that if the soldier initially points to the monkey because of the projectile motion, then the bullet should undergo the projectile motion, and it should not hit the monkey. Is it? But the monkey is not as clever as me. So what the monkey will do? when the monkey heard the sound, and the monkey will just fall. And because of this, because both the monkey and the soldier make a mistake, and finally the bullet hits the monkey. Now then we are going to analyze this motion by using vector. This is the most easiest way to understand why he can hit the monkey. Now I start with the formula S equal to ut plus half at squared. So this is a bullet. Initially, the U is pointing towards to the monkey. Okay. Now I need to rewrite this formula in vector form. Hope you still remember how we add the two vectors. So U times T will be this vector, U times T. And then half AT squared, because A is downwards, G, so it should be downwards. The displacement of the bullet will be the blue arrow, this one. The sum of these two. That is a displacement of the ball, of the bullet. And then because the monkey, the monkey is just free falling. The monkey is just free falling. So for the monkey, it has no initial velocity. Good. The displacement of the monkey will be just half AT squared, the A is G. So that's why you can see that the bullet can really hit the monkey by using simple vector diagram. Just given that the bullet or the gun initially points towards the monkey, no matter how fast or how slow the bullet is, the bullet can always hit the monkey. Okay. So then let's take a look at some of the, let's say for this one, this is a Hong Kong A-level past paper. It just means the monkey and hunter experiment. So and then you want to see if the bullet is to strike the target, so the angle theta should depends on what. We say that whenever the bullet or the gun points towards the monkey, it can always hit the monkey. So you take a look at this triangle. So that's why the angle theta should be, tangent theta should be h over d. So that means the theta should depend on h and d. So the answer should be h and d, not depends on u. Okay. Okay. Now question MC number 4 is another variation of the monkey and hunter experiment. So the gun hits a bullet. Now the bullet leaves the gun at the speed 50 meters per second. And because it undergoes a projectile motion, it will not hit the point P. I want you to find the distance separation between the bullet and the point P when the bullet is vertical below the point P. You want to find the distance here. Now, in other words, it actually wants you to find the displacement of the monkey, is it? Then what is the displacement of the monkey? It's just half gt squared. Then we need to know the time. So how can we solve the time? If you still remember what I use is u vector u times t. This is half at squared. Then this one equal to the magnitude of ut should be 40. U is 50 times time equal to 40. So that's why we get the time is 0.8. The time is 0.8. Then you solve it, then you get the answer 3.2. So therefore the answer should be A. Okay. It's not on the. Hold on. Now we finished the DSC part of the projectile motion 㗎啦吓. We just skip some of the part like drawing the graph and relating the motion with the energy. But whatever, okay, whatever. We have finished the DSC part 㗎啦. And then the next session, then we'll go on to take a look at the some Olympic question on projectile motion. Okay, so that's it for today. Do you have any questions?
How is A level